this video, we'll be looking at the second part of how humans respond to the environment, which is through the endocrine system. We previously looked at the nervous system, which was the peripheral nervous system, the central nervous system, and everything that was involved there. And now, looking at the human endocrine system, it is asked in paper 1, and then your exam guidelines will once again tell you everything that you need to know of what to leave out and what to study. So we are going to look at the difference between an endocrine and an exocrine gland, which should not be strange to you as you have done that in grade 11. Then the definition of a hormone. We're going to look at the glands and where they are found, and then the hormones that they release and what the functions of those hormones are. And then lastly, we'll look at the negative feedback mechanism, specifically for TSH and thyroxine, and then insulin and glucagon. Now, before we get into exocrine and endocrine glands, let's just look at what the endocrine system actually does. So the endocrine system uses chemical messages, hormones, that are produced by glands to regulate the function of different organs. Now, when we did the nervous system, I gave a quick breakdown of the differences between the two systems, the nervous system and the endocrine system. So let's just quickly look at that again. The nervous system, the response is controlled by the brain and the spinal cord, so the central nervous system. And then now with the endocrine system, we are going to see that glands play a big role in how responses are controlled. The response of the nervous system was in the form of impulses, electrical messages, whereas with the endocrine system, we will see that this is done through hormones or chemical messages. Then the response in the nervous system was carried by neurons, the interneuron, motor neuron, and sensory neuron. And then the endocrine system, this is done by the human circulatory system, which is blood. The response time of the nervous system, it is extremely quickly. I'm referring specifically to the reflex arc, which happens in seconds, and that is done to protect the human body against further injury. And then the endocrine system is rapid, but then there are also slower responses. So it can happen anything from seconds to hours. I'm talking here about adrenaline, that is your fight or flight hormone, and then other hormones that will take a bit longer to have their action fulfilled. So looking at what the definition of a hormone is. So hormones are organic chemical messengers that are secreted directly into the bloodstream by a gland. These hormones cause specific organs to perform a specific function. So we know that the human body is made up of organs, and these organs are made up of tissues, and these tissues are made up of cells, and all of these are controlled by the nervous system and then the endocrine system. They are controlled. Okay, so let's look at the difference between an endocrine gland and then an exocrine gland. So endocrine glands are glands that secrete hormones directly into the bloodstream to regulate specific organs. And this is the thyroid, the pancreas, the adrenal glands, the pituitary gland, the hypothalamus, ovaries, and testes. We'll look at all of these now. And then the exocrine glands are glands that secrete substances into ducts that lead to cavities or the external environment. So exocrine glands, mainly looked at them in grade 11 when you did the human digestive system, so in nutrition. And there's the salivary glands, pancreas, sweat glands, and the liver and mammary glands are examples of that. Now we'll move on and we'll look at where these glands are situated, what hormones they secrete, and what functions they basically have. So the most important of them is the hypothalamus. And the reason I'm saying the hypothalamus is quite important is it is basically the control center of the endocrine system. It sends hormones to the pituitary gland, and then the pituitary gland is more like the master gland or the master key of the body, because then it will direct other glands in the body to secrete hormones and perform different functions. Looking at the diagram on the right of the brain, this area that is enlarged here is where you would find the hypothalamus and the pituitary gland. So the hypothalamus is this area over here, and then the pituitary gland are these two dangling things that you see here. And you get an anterior and a posterior side of the pituitary gland, but you do not need to know that. So let's look at what the function is of the control center, the hypothalamus. What does it do? So the hypothalamus has plenty of hormones that it secretes, and it sends it to the pituitary gland. But for now, based on what the exam guidelines want us to do and know, we are only going to look at one specific hormone there, and it's called ADH. And that stands for the antidiuretic hormone. Now, once again, this hormone should look familiar as you did it in grade 11 when you did the human excretory system. So ADH, antidiuretic hormone, what is the function of this hormone? Basically, it controls the concentration of water in the blood in the kidney. So this is reabsorption of water by making the walls of the renal tubules and collecting ducts more permeable to water. Next, we're going to look at the pituitary gland, that little section there, and if you zoom in, that area over here. So the pituitary gland has got quite a few hormones that it secretes. So the first one we'll be looking at is GH, the growth hormone. Now, many of these hormones, it's very easy to remember what they stand for. So the growth hormone does exactly what the name says. It promotes growth of your muscles and the skeleton by stimulating the synthesis of proteins. So the production of proteins are triggered or stimulated by the growth hormone that is produced by the pituitary gland. The next hormone that is also secreted by the pituitary gland is called TSH. And TSH stands for thyroid stimulating hormone. So this hormone will work directly with the thyroid gland. And what TSH does is it stimulates the thyroid to secrete thyroxine. So it stimulates the thyroid to produce its own hormone called thyroxine. Okay, we'll look at that a bit later on. So TSH also produced by the pituitary gland. Then another one produced by the pituitary gland is FSH. Sorry, my writing is horrible again. FSH. And FSH stands for follicle stimulating hormone. This we did when we looked at human reproduction, specifically the menstrual cycle. We looked at FSH. So what does FSH do? It stimulates the development of the primary follicle into the Graafian follicle. This is in females, and then in males it activates the epithelium to produce sperm in the testes. So remember the testes had that epithelial lining, and that is where, in the epididymis, where sperm production took place. Then the last two that we'll look at is LH, which is also part of the menstrual cycle that we looked at, luteinizing hormone, and this stimulates ovulation and the development of the corpus luteum in the ovaries of females, and then in males it stimulates the cells of Leydig to produce testosterone. Then lastly we will look at prolactin. So prolactin stimulates the mammary glands to produce milk after birth. And that is the pituitary gland. The pituitary gland is also known as let me write it here at the bottom, the hypophysis. Ugly writing, that's one word, sorry. Hypophysis. I prefer pituitary gland so you don't confuse it with a hypothesis that you would do with an investigative question. Okay, So that is the pituitary gland. Next is the thyroid, which sits over here, that butterfly-like structure, and the thyroid produces the hormone thyroxine. So what is the function of thyroxine? It increases your basal metabolic rate, so that is the amount of energy that you need when your body is at rest. It increases your breathing and heart rate. It promotes normal growth and development of your organs, and then normal functioning of the nervous system. And we'll look at what happens if the thyroid does not function properly. What happens to your health then? So that is the thyroid gland. Then next is the pancreas, which sits over here. Now the pancreas, also nothing strange, as you did it in grade 11 with digestion as well. So specifically here it is the islets of Langerhans that produce insulin and then glucagon as well. So the pancreas is both an endocrine and an exocrine gland. Exocrine because it releases the pancreatic juice into the small intestine, whereas with the endocrine gland, you know, it releases insulin and glucagon directly into the bloodstream. We will also be looking at these two hormones in a bit more detail later on in the video when we look at the negative feedback mechanism. So just basically what insulin does, it decreases the blood glucose levels by stimulating the conversion of glucose into glycogen in liver and muscles, and then it also stimulates the absorption of glucose into body cells from the blood. Then glucagon, it increases the glucose levels by stimulating the conversion of glycogen into glucose in the liver. Let's carry on to the next gland, which is the adrenal glands. So the adrenal glands are these triangular shaped structures that sit above the kidney. So you know your kidneys, that system specifically is known as the renal system as well, so adrenal. That is why it's called the adrenal glands. So what the adrenal glands do is they secrete two specific hormones that we'll be looking at. The one is adrenaline, which you are very familiar with, your fight or your flight hormone, and then the other one is aldosterone, which you also talked about, well, you did that work in grade 11. So adrenaline, what does it do? It accelerates the heart rate. It increases the blood pressure as blood vessels through the skin and intestines constrict. It accelerates the conversion of glycogen to glucose. Remember, this is the fight or flight hormone. So glucose is very quick energy, so that is why you want more glucose. Then it increases the rate and depth of breathing by dilating the bronchi. And once again, this is to circulate your blood in your body quicker. That's why the heart rate accelerates, the breathing rate is increased so that oxygenated blood can reach your muscles quicker. It increases muscle tone, dilates the pupil so you can see better, increases sweat production to cool the body down. There's a whole list of things, and they have asked adrenaline in previous essay questions how their body responds. For example, this boy is playing outside with a soccer ball, and then a snake comes out of the bushes, and it has to do with the eyes, and then adrenaline, because there's a snake coming towards him, you can see the snake with his eyes, so it's going to be accommodation, the process of accommodation that happens. So it gets really in depth with those essay questions. Then adrenaline, we've done now. So aldosterone, it increases the reabsorption of sodium and chloride ions from the filtrate in the renal tubules, and this facilitates the movement of potassium ions from the blood to the filtrate. So once again, in the kidneys is where the function of aldosterone is performed. Then ovaries, there we are looking at the hormone estrogen. So estrogen, the function there is for secondary female characteristics to develop. So basically the development of female sex organs during puberty, and the secondary female characteristics, broader hips, breast development, all of those things that accompany secondary female characteristics. Then the thickening of the endometrium and the preparation of the uterus for implantation. and then it also inhibits the secretion of FSH. Also secreted by the ovaries is progesterone, and that is specifically secreted by the corpus luteum. So I don't know if you can remember the corpus luteum. Don't confuse it now with the corpus callosum of the brain. The corpus luteum is that yellow pineapple-like structure. That's a very horrible drawing of the corpus luteum, but that yellow pineapple-like structure that you would find in the ovaries after ovulation has occurred. So the corpus luteum secretes progesterone, and the function there is the thickening of the endometrium and the maintenance of the endometrium during pregnancy, and then it inhibits the release of FSH and LH. So once again, you don't want any follicle stimulating hormones involved there, as they will stimulate the production of a new egg cell, which you do not want, as there's already a potential successful pregnancy underway. Then the last one in the testes is testosterone. So testosterone specifically secreted by the cells of Leydig, and there also secondary male characteristics, deepening of the voice, facial hair, pubic hair, development of male sex organs during puberty, and then the maturation of sperm, and it also contributes to the quality of the sperm. So that's all of the hormones that you need to know about, and then the glands and where they are situated. So it's really not that much to know, and it's very basic. If you just look at this structure in the drawings, it's not that hard. Next, we'll move on to the negative feedback mechanism. So what is the negative feedback mechanism? It is the detection of a deviation away from the normal results in a reaction that will counteract what has happened and bring it back to normal. The return to normal is detected and the corrective action is stopped. So this also works hand in hand with homeostasis, which is a constant internal environment that you would want to be kept. So the negative feedback mechanism walks hand in hand with homeostasis. It helps maintain homeostasis. So we have to look at two negative feedback mechanisms. So the first one is between TSH, the thyroid stimulating hormone, and thyroxine, and then we'll look at insulin specifically, and what will happen if there's a defect there. So with TSH and thyroxine, so when the thyroxine levels are below normal, so when the thyroid has not secreted enough thyroxine, the pituitary gland in the brain will secrete more TSH, so the thyroid stimulating hormone. What that hormone is going to do, it's going to stimulate the thyroid to secrete more thyroxine. And because it's stimulating the thyroxine levels will increase, and when the thyroxine levels are above normal, the TSH secretion will be inhibited. So the pituitary gland stops its function then in secreting TSH, because now we don't want the thyroid to secrete any more of thyroxine. So less TSH secreted, which means less thyroxine is produced. So once again, negative feedback is very much when one hormone inhibits the secretion of the other. What will happen if there's an imbalance? So specifically, you'll get quite a few thyroid disorders. You'll get hyperthyroidism and hyperthyroidism. So when there's an oversecretion of thyroxine, you'll get hyperthyroidism. And what happens when you have that? There will be an increase in the metabolic rate, which means there will be some weight loss. There's also an increase in heart rate, respiration rate, and then blood pressure. When there's an undersecretion of thyroxine, you'll have hypothyroidism, which means you'll have a lowered metabolism. Generally, when people have trouble with weight, we'll look at in adults, it specifically this point over here, a lowered metabolism will cause an increase in body mass. So if there's somebody that is struggling to lose weight, one of the things that the doctor will do is he'll feel over your throat area, because that's where your thyroid sits. Basically, if you swallow, in guys, your Adam's apple, and in girls, if you swallow and you feel something moving up and down, that is the thyroid that you are feeling. So in children, it causes cretinism. So they don't grow normally, they are mentally disabled, and they don't reach sexual maturity. Whereas in adults, it causes myxedema. There'll be a mental decline, physical lethargy, increase in body mass, and thickening of skin. So that is what you need to know under thyroid disorders. Next, we'll look at negative feedback between insulin and glucagon. So once again, these are secreted in the pancreas, specifically in the islets of Langerhans. You've got alpha cells and beta cells, which are involved with this whole process. So when the glucose levels of the blood are above normal, which means that there's a high concentration of glucose in the blood, the beta cells in the pancreas will detect this, and they will secrete insulin. Insulin will then stimulate the absorption and conversion of glucose into glycogen. The glucose concentration is then lowered because the glucose has been taken out of the blood and stored as glycogen. This lowered concentration is then detected by the beta cells, and then the insulin secretion is inhibited. Once the glucose concentration goes below normal, so when it's very low, the alpha cells in the pancreas detect this and they secrete glucagon. So glucagon will then go and convert glycogen back to glucose, and thus the glucose enters the blood again and the glucose concentration is increased. Now, this increase in the glucose concentration is then detected by the alpha cells once again, and then the glucagon secretion is inhibited. And this happens the whole day. This, you can almost say it's a little seesaw effect. As the one goes up, the other one goes down. If the one goes up, the other one goes down. And this happens the whole day. Specifically after meals, you'll have an increase in your blood glucose levels. So what happens when this system does not work properly? Then you get diabetes. So diabetes is a chronic disease, generally characterized by high blood glucose levels, and this is because insulin is either absent or it doesn't function properly, and then there's an increase in your blood glucose level. So what are the symptoms that you can experience with diabetes? So there'll be an increase in hunger, frequent urination, especially at night, increased thirst, always thirsty, can never have enough water. There'll be weight loss, repeated infections, so wounds heal slowly as well, impaired vision, exhaustion, and dizziness. These are all symptoms associated with diabetes. But now there are two types of diabetes: diabetes type 1 and diabetes type 2. So type 1 is not that type 2 isn't a serious form of diabetes, but type 1 is pretty serious. So this is when the insulin-producing beta cells of the body is destroyed by its own immune system attacking its own cells. So your body physically is breaking down its own cells. And this then leads to little or no insulin being produced, because that is done with those beta cells. So the treatment here would be daily insulin injections. In serious cases, you can even get a insulin pump that is built in that will do these injections for you. Special diet needs to be followed, and then regular blood sugar level testing. So you'll see that people generally after meals, they'll have those little machines where the finger is pricked, and then they then put the blood on those little platelets and then into the machine that will give them a reading. Type 2. So this is a lifestyle disease. This is purely because people have been eating wrong and they haven't been looking after their body. So you'll see overweight or obese people with this, or inactive people, and it can also come with age. So insulin resistance is the main feature here. So insulin is produced by the body, but it cannot be used effectively. So the treatment of this is a balanced diet, not eating a lot of carbohydrates because those contain sugars, very little fruit, especially no cold drinks like Coca-Cola that has quite a lot of sugar in it, but then also regular exercise, and then oral medication or insulin is then used to treat this. And that is the end of this video on the endocrine system. It's really not that bad. In fact, I find this specific chapter very interesting, especially with all of the hormones and what they do and if something goes wrong. So yes, study hard.